So let's take a moment and talk about electronegativity. So what actually is electronegativity? It describes the unequal sharing of electrons between atoms. So once you hear that sharing between atoms, it should bring up some thoughts about what you know about bonding thus far. So electronegativity, more specifically, describes the ability of an atom in a molecule to attract a shared electron to itself. So the higher the value of the electronegativity, the more the electron in the bond resides near the atom. So it's almost like a popularity contest for electrons, if you'd like to think about it that way. So we basically measure electronegativity by the polarities of the bonds between various atoms. And there's actually a numerical value associated with electronegativity, and it ranges from 4.0 to 0.7. And so this schematic here is kind of, you imagine, it's a faux periodic table, if you will. And so electronegativity increases as you go to the right towards the nonmetals, with fluorine being the most electronegative atom with a value of 4.0. And electronegativity decreases as you go down the periodic table, with cesium having the lowest electronegativity of 0.7. So if you think about that and what you know about these respective elements at this point, you know fluorine loves negative energy. So it loves electrons. So it's electron loving. So that's why it is the most electronegative atom. Versus cesium is kind of large and pretty soft, and it prefers to lose its electron so that it can gain a positive charge and become like the noble gases. Okay, so let's kind of look at that a little, in a diagram form, if you will. So here I've depicted a bond between hydrogen and hydrogen. So remember that this line here is representative of two electrons, right? So here in this bond, these two elements are the same. No one is more popular than the other with the electron. So the two electrons here are equally shared, as depicted here, okay?